Hello, I'm Thomas from Geon Technologies, and welcome to Property Kinds Part 3, Message. We'll be continuing where we left off on Part 2, so please complete the previous sections before actually attempting this one. At the end of Part 2, we had our modified sawtooth device, which we could now initialize to a specific window size of samples and allocate a sampling frequency, which also acted as a single user reservation of the device. We also experimented with a waveform that had a user-device relationship to dynamically establish that single user reservation to its internal pass-through component, the data converter. From Part 1, we also created a reconfigurable structure of properties called control params so that we could tweak the sawtooth's amplitude and frequency while it was running. And now for Part 3, we'll be converting that structure to a message so that a new component, sawcontrol, can control the sawtooth simply by knowing that structure's IDs. We will also employ a user-device relationship from Part 2 to allow both components to connect to the same reserved sawtooth device. Our first step then is to modify the sawtooth device's project. Under Properties, select the control params and check Message. Now, why would we choose to make a property a message if it means that we have to give up the benefits of some of the other kinds, like configure? Well, simply put, message gives you a very simplified way to implement your own asynchronous and structured port type. But, because it's custom, maintenance is completely on you. Every change potentially breaks compatibility with other users of that particular port. If you're looking to standardize a device's interfaces and avoid that problem, use one defined in front end, even if it describes more than what your device can actually offer. It will allow both the device and component design teams to work in parallel. We'll be covering front end in a different session. For now though, this simple signal generator's interface is a nice candidate for showing how to easily convey a structure between entities. Uncheck Configure so we can continue. As discussed in the introduction session, what is REDHAWK? All data being passed between entities is conveyed on ports. A message property will be entering or exiting an entity, so we need a port to carry it. Over on the Overview tab, add a port named Message. This device will be receiving messages, so the port must be bidirectional and its type is message event. So why bidirectional? The underlying infrastructure is still a remote procedure call, but the consumer might need to use the underlying event channel, therefore making it bidirectional. Save and generate the source files and open the sawtooth device PI file. We need to make two more changes to this device. The first change is that our onConfigureProp method is no longer applicable. It needs to be a callback. So from our code blocks, there. You'll notice this callback gets a message ID and the new value rather than the old value and the new value. This ID will correspond to that of the top-level structure's property and a new structure which brings up an important point about the message event port. A single port can convey several different messages. Next up, the receiver of a message needs to be prepared for the near certainty that the associated property may not have a value initially. So let's handle this in the initialization function. Here we set both frequency and amplitude to 0, as we originally had the default values when this was a configure property. Also notice that on the particular named port, we can register our callback for a specific property ID. This registration also includes a mangled reference to the message structure's definition found in the base class. See how control_params became capital C control, capital P params? It's just another nuance to keep in mind. You can always find the mangled name by looking in the base class declaration file. Save and install the sawtooth device to the target SDR so we can shortcut our update of sawcontrol. It needs similar changes, a port and a property matching the message. Open the project for sawcontrol and add the new port, also named message. It's the source, so its direction is an output, uses. For the interface type, again select message event. Over in the Properties tab, we'll add our message property. But because we already installed the device in the target SDR, this message structure is now known to the IDE. We can use that as a shortcut using the Browse button. Simply expand the target SDR, Devices, and our device. Select the Control Params property and hit Finish. As you can see, the property is already marked as a message and includes all defined IDs for that structure, amplitude and frequency in this case. Save and generate the implementations. Now over in the sawcontrol .py file, we need to update the process method so that each time the service function is called, we update our message. From the code blocks, we have a few quick lines for this. The first thing that you should recognize is that the property name mangling, as we saw in the device, is present here too. And more importantly, notice that the structure is defined here as well, in this entity's base class, not the device that originally defined it. This is why changing message definitions down the road can cause code maintenance issues, so make sure you standardize if you can. Here we're using a local variable for the structure, but you can refactor the component to use the message property if you like. The last step, send message, gives a clearer indication of why the destination is bidirectional. Save and install the component to the target SDR. It's time to add it to our waveform. Open the controller waveforms project and view its diagram. And from the components list on the right, drag in sawcontrol. Next, we need to leverage the uses device relationship in this waveform to also connect our component's message port to the message port on whatever matching device is found when the waveform is launched. So in the XML tab, we need that relationship and the other connect interface. So in the XML tab, we see that relationship and the other connect interface for the data converter. Use the other connect interface from the code blocks to define the relationship between our sawcontrol component's message port and this uses device reference port. Now if a device is found that can allocate SampleFreak, both named ports will be connected to that one device. Keep in mind that device is still only being used or reserved by a single user, which is the waveform. It just so happens that the waveform intends to connect that device to two different things. Save and install the waveform to the target SDR. It's time to test. Use the target SDR to launch the domain and SIGGEN node as you did before. And once they're up, launch and auto-start the waveform. Again, the sawtooth device is allocated and starts automatically. Here I'm going to use the Python shell, as we have before, to connect two different plots to the data converter component's data float output port. This process should look really familiar at this point, so I'm not going to go into it in much detail. And forgive the lag in the virtual machine displays. You can somewhat make out the analog waveform in the right plot sweeping through frequency. The spectral plot, to the left, also shows the familiar look of a sawtooth in the frequency domain. At the end of part 2, I mentioned, but didn't show, that releasing the waveform will stop the device because SampleFreak will get deallocated. And as you can see, that's true. Releasing the waveform deallocated the property and the device stopped. Though we've skipped exploring the event kind, that's it for this discussion on messages and the property kind series. Some key points from this session on messaging. Message properties can be no other kind. Messages leave an entity and are therefore carried on message event ports. These message event ports can carry several messages. The destination implements a bidirectional and the source implements a uses port, though of course both could be bidirectional if that's the intended data flow. Message property may not have a value when the entity attempts to read it the first time. The property structure is defined with a mangled name in the entity's base class. Thanks for watching. Again, I'm Thomas with Geon Technologies. Please feel free to contact us for more information or in-class training.